Any success with this one? That was underwhelming. So I don't know if you were listening when she asked what kind of problem it is, and so since we're starting our review for the test on Wednesday, I think it's good to start practicing that. Here's what I would think through if I was you. And our notes are kind of broken into sections. So the first stuff was some review of area and circumference. So I would say, is this an area or circumference problem? No, it's not. So again, the question is asking, what's the diameter? And I'm not saying for sure that that's right in the middle of the circle, but it's talking about how wide that circle is. We could also do it this way, too. Okay? So it's good to know what a diameter is, but it's not any of this work. Okay, from there we went into the equation of a circle, which is definitely not that. This was just terms like understanding what we're talking about. Okay, the next section, we did talk about arc measure and arc length. So arc measure would be like what angle is that? So that may or may not play a role, but it's definitely not what we're solving for. And then arc length would be like how much of the pipe do they have to paint with smooth, like slippery paint or whatever. Like that would be arc length, but that's not what it's asking. Okay, then we did the area ones. So area of a sector, area of a segment. Okay, well this piece right here where the water flows is an area of the circle, but it's not asking for that. A different problem might ask, like, what's the cross-sectional area of the flow of water or something, maybe for flow rate, okay? But this one's not asking that. Okay, then we got into tangents. So tangents, remember, touch the circle on the outside of the circle at only one point, that point of tangency. So that would be things like, maybe that, like, where is this tangent to the circle or something? Or if we were going to do some supports that touch the circle at just one place, but that's not what this is asking. Okay? Then we got into chords. So remember, chords were segments that touch the circle at their endpoints. So endpoints on the circle. And that right there is a chord. The surface of the water functions like a chord of the circle. So this could be it, right? Like just conceptually it could be. Well, we had 4 different chord theorems. And sometimes they kind of interact, but this one is specifically talking about diameters and bisecting this chord and that kind of thing. So the typical picture, I don't know if you noticed, actually I did ask you this on Friday. So a lot of the chord problems end up with some kind of picture like this. Let me draw it better actually. I guess we could come up with some kind of a name of this. But it has a lot of problems had to do with that, right? And we were either solving for the distance that the chord was from the center, or perhaps the length of the chord, or maybe the radius. Those were kind of the things that we solved for. So with that knowledge, we've narrowed it down to concept that we can apply. Now we need to start either adding to our picture or maybe zooming in on parts, redrawing it so that we start to see what relationships are involved. Okay? And this isn't just specific to this problem. I'm kind of talking you through a process that you can use in general, right? On this quiz. So, I think first, obviously we have, for this water slide, we only have part of the circle actually existing, but we know it's part of the circle. Okay, the chord is 8 feet, so draw in that 8 feet chord. I think I'll put it a little lower. 8 feet. That's going to be right where I want the radius. Okay, it tells us it's 2 feet from what we would consider the bottom of the pipe. Okay. And it wants to know, she wants the waterway to be 8 feet wide when the water is 2 feet. What is the diameter? Okay. So what are you thinking in terms of picture? Like what can we add to it? Etc.
I was thinking like 2 lines from the court connecting to like the radius.
Okay, so setting up our typical picture, maybe? I think that's what you mean. And we'll just label those R since we don't know what that is. And then as soon as I draw this, I kind of like to split the 8 because we know that any radius we draw in there is perpendicular to the blue chord. So I'm saying do 8. Wait, it was 8. So it's 4 and 4. 4 and 4. Okay? So, a couple things we can think through. That is half of the diameter. So as soon as we know the radius, the diameter is easy to get, right? So potentially we could be looking at solving for that distance, and then we would add 2. I'm saying potentially because we haven't talked through everything. Any other thoughts? But do you kind of see how we're developing this problem? Okay, your quiz is it's not going to always have word problems like this or in context ones. In fact, most of them aren't. So I guess what I'm saying is you don't always have to draw your own picture all the way, but you might have to add to it based on theorems and stuff that you know. Okay. Well, what were the typical solving tools that we had? Thinking of that sheet that we worked on, some on Thursday and some on Friday. What were, well, and we did a little before that as well, actually. What were some of the tools that you had in terms of solving this kind of stuff? If I go back to the note picture when I said we can solve for those 3 things. Actually, and angles too. But what were your tools? What are you solving with? Okay, maybe trig ratios. Okay, which is a squared plus b squared equals c squared. What do both of these require us to have to be able to use? Yeah, the right angle. So that theorem is what gives us the right angle, right? Okay. All right, what else? Okay, so this one, how should I say it? I'll ask it this way. Should you just assume that it's 2 here also? Is that an okay assumption? Okay, so be careful with those. That's just general advice. Don't copy paste things too much. Did anybody get this far? So, like in the work time? Okay. I'm going to give you, I want to not just roll over your think time. So I want, now that I've kind of helped set up the picture some, I want you to take, I'm not going to let you go too far, or too long rather. Take like a minute or 2 to kind of think through it. See if you can develop some more from here, okay? But again, I don't want to take too much time. Okay, here's the thing. we don't know that little purple length, and we can't just put something in there like we said a second ago. So let's just call this x for now. And then do you agree that x plus 2 is equivalent to the radius? Okay. So instead of writing r, we could rewrite these radius lengths in terms of x so that we don't have two variables floating around. Do you see how to solve it now? Okay. What angle is that right there? That's a 90. So we'll just use the Pythagorean theorem, and we'll be able to solve for x using that. So 4 squared plus x squared equals x plus 2 squared. Do you see what I mean by it looks kind of more algebraic than what we were doing? Okay. Reminder on this kind. Let me get to it. Remember that this is not x squared plus 4. Because why? What does squared mean? Times itself. So it means x plus 2, that whole thing, times another one. Okay? And then we have to distribute that out, like do this whole, if you want, you can write the lines. But we have to do that whole thing. So x squared plus 2x plus 2x plus 4. And then combine your like terms in the middle. Good? Okay. And then solve from there. How do we solve? Yeah, across the equal sign we want to combine like terms, right? So I would start by getting rid of these so that we don't have to deal with the quadratic. In this case they cancel, which is nice. Okay, what would you do now?
Subtract 4.
Yeah. And then just divide to get 3. Well, 3 what? We should probably label that. Like, what is all of this stuff? It's feet, yeah. Okay, so it's 3 feet for x. Now, don't forget this isn't what the question asked for, right? So x is 3 feet. So what is r? So the radius equals 5 feet. So the diameter is actually 10 feet. I'm going to kind of draw it as if the diameter was right at the top. So this is a huge pipe, right? Like if it was actually in all the way around as a cylinder, it would just touch the floor and the ceiling of this room. That's big, huh? Okay. But have you been in one like that before? Have you ever gone to a water park, a big slide like this? Okay. Cool. Your quiz will cover all the stuff that we just reviewed a few minutes ago. So I think I'm going to make an executive decision and let you use the notes part of your notes, but not the examples part. Are you willing to tear those off for the quiz, I mean? And then we can restaple them later if you want. Yeah.
Will you be grading it as a test?
Well,